Last time I was here giving a talk in Gardner, there were like 7 people here. Now I'm like, we put out like 28 chairs or 30 chairs thinking optimistically, and gotten a lot more. So thanks a ton for being here. My name's Mike Poland. So I'm the scientist in charge of the Yellowstone Volcano Observatory, and what I wanted to talk to you a little bit about today, if it's of interest to you, are hydrothermal explosions. Because that seems like it might be kind of the topic of the year. But before I get started, I'm just sort of curious, are there a lot of sort of guides here or local folks? Wow. Real local. Real. And are there folks from out of town? I know there's a large contingent. Well, I hope this is of interest. What I'll do is I'm just going to sort of talk for about half an hour about mostly hydrothermal explosions, since it's topic of the year, really. And then I want to open it up for questions. And you can ask anything you want, about I may not answer it, but geology would be good if you want an answer out of it. And then and we can sort of go wherever that is. So I figure maybe 30 minutes I can show you some cool things, I hope, and then we'll just sort of open it up for questions. But I wanted to start it up with a bit of trivia, a couple of trivia questions. I do have some fabulous prizes. So,
I want to walk out at Biscuit Basin. Come on, would that be a prize?
that's not a prize. So the first question will be, the largest hydrothermal explosion crater in the world is in Yellowstone. Does anyone know what it is?
Mary Bay.
Who said Mary Bay first? All right. You can have either the USGS benchmark patch or the USGS benchmark keychain. Patch. All right. Well done. All right. Now, for the keychain, you probably all know about the Biscuit Basin Explosion. Made all the headlines. There was another explosion this year that did not make as many headlines.
Norris.
It was at Norris.
And you posted the day before Biscuit Basin. How did that happen?
I'm good.
Yeah, how did you know?
So what we are referring to here is we were very excited about this explosion in Norris, which I'll talk about in a couple of minutes. And we have a product that we call Caldera Chronicles, where we talk about some aspect of Yellowstone geology or geologic history or new research. And we put something like on Caldera Chronicles every Monday. And on Monday, July 22nd, we finally sort of galvanized ourselves and got the park involved. And we're going to talk about this explosion at Norris. And I was super excited. We detected a hydrothermal explosion. And the next day, Biscuit Basin exploded. So we lost a little bit of oomph on that one, but gained it in other places. So, okay, so let's dive in. And if you have questions, please just chime in or throw your hand up or whatever you like. I don't want to speed through things if you're wondering about stuff. So this is sort of the way I'd like the evening to go. I want to start out and talk about geologic hazards in Yellowstone. And then we're going to talk about some recent hydrothermal explosions. Biscuit Basin, the one that happened at Norris earlier this year, and then just a couple of others. I just want to throw them in there because they're pretty famous ones, and we've learned some things about how these explosions work from those. And then I want to get to the big questions. How often do these things occur? Where are they most likely to occur, and why do they occur? And then can end by talking about a little bit of monitoring and forecasting, and then just have some discussion. That sounds okay. All right, so geologic hazards in the Yellowstone region. Here we are, obviously Yellowstone National Park. We're up in Gardner. The hazard that most people think about when they're talking about Yellowstone volcanism is and I have a hard time saying this, super eruption. Some of you may know, and I will only say this once right now, I'll only say this word once, I hate the term supervolcano. I hate it. And I refuse to say it except to say how much I hate it. I would prefer to think of these as caldera systems because they do a lot of things, as you're going to see. They do have very large eruptions, and there have been 3 really big ones in the last 2.1 million years. So this green one, that's sort of the dashed outline, is the Huckleberry Ridge caldera. That formed 2.1 million years ago. Then there was the Henry's Fork caldera. That was 1.3 million years ago. And then Yellowstone caldera was 631,000 years ago. So when those things happen, they put a tremendous amount of ash up into the stratosphere. There's almost certainly global climate impacts. The impacts around here are just absolutely devastating because of the big ash flows that sort of sweep the landscape. And then this is sort of a map of ashfall thicknesses that we've modeled for eruptions like this. It's probably hard to see, but you're looking at in the, well, let's go to Denver. My sister lives in Denver, and she'd be getting about a meter of ash, somewhere between 10 centimeters and a meter of ash. So it would be pretty significant if one of these events happened. Now, fortunately, we're not too worried about anything like this because the magma we know beneath the Yellowstone caldera is mostly solid. We pass seismic waves through it. It's kind of like taking an MRI of the Earth, and it's about maybe 20% molten or so. It's really not enough oomph to feed an eruption like this. So we're not particularly worried about a big caldera-forming event. Slightly more frequent than these big caldera-forming events are lava flows. There have been about 30 or so lava flows since the last caldera-forming eruption. All of these pink units and the orange ones are lava flows. That's why you can't see a big hole in the ground at Yellowstone, is that it's largely full of lava flows that have erupted after the big caldera-forming event. If you want to see the guts of one of these flows, go to the Grand Canyon of the Yellowstone. You're sort of seeing into the interior of some of these flows. Obsidian all over the park from these lava flows. So these are slightly more frequent. They seem to happen in episodes. The last flow was the Pitchstone Plateau 70,000 years ago. No lava magma has reached the surface since that Pitchstone Plateau lava flow. So no eruptions, no volcanic eruptions in the last 70,000 years. All right, now let's get to stuff that's happening on human timescales. Strong earthquakes. These are in the magnitude 6 to 7 range especially. There have been 2 historic ones. Magnitude 7.3, 65 years ago last month. Just west of the park at Hebgen Lake. Caused a huge landslide, dammed the Madison River. Unfortunately, the landslide swept through a campground just before midnight, and there were over 24 people were killed by that event. That's something that can really affect the whole region, and it's caused by pre-existing faults that are already present all throughout this area. It has nothing to do with the volcano. There was also a magnitude 6 in 1975 at Norris. So you can have magnitude 6 and 7 earthquakes in this region. And they're not related to the volcano, not caused by the volcano. And then we've got hydrothermal explosions. There's a number of them on the north side of Yellowstone Lake, within the lake, on the side of the lake, up in Lower Geyser Basin, even up near Roaring Mountain. And these are not volcanic eruptions. They're caused when water flashes to steam. And there's a number of ways in which that can happen. And that's going to be really the topic of the evening. Some of them are pretty small, but some of them can be pretty big. So Mary Bay on the north side of Yellowstone Lake, it's 1.5 miles across. It's a steam-driven event, not caused by a volcanic eruption. So these things can be huge. Biggest one in the world, right here in Yellowstone. But then you get little small ones too. And the small ones happen probably a couple of times a year, somewhere in Yellowstone. So if we were to try to plot this out and say the most frequent hazards plot up here, and the most destructive ones plot out here, we'd put those big caldera-forming eruptions way out that way. They're extremely destructive, but you only get maybe 1 or 2 per million years. So very infrequent, but very destructive when they happen. Lava flows, well, less destructive, but a little bit more frequent than these caldera-forming events. Strong earthquakes, you get maybe 1 to several per century. Not quite as destructive as a big volcanic eruption, but much more frequent. And then the hydrothermal explosions. We can have many of these per century. Small ones happen annually. The big ones happen every few decades. And that's what I want to talk about for the rest of the evening, are these hydrothermal explosions, because of that.
That's what it looked like under the house.
This person did the right thing. That was the view up close. Can we get it again? Why did it become so long? And then we've got the view from the road, which is mind-boggling. Somebody pulled out their phone as they were driving past, and that's what it looked like. Probably went 400 to 600 feet into the air. So, that's, Old Faithful is like 100 feet or so, so you're looking at 4 to 6 times the height of an Old Faithful eruption. So that was Biscuit Basin on the morning of July 23rd. This is what the aftermath looked like in the boardwalk area where all those people were standing. following the explosion, a team of geologists went out and mapped all of the rocks out there. They mapped 1,500 rocks that were bigger than 1.5 feet in one dimension. So, I mean, it is pretty incredible that no one was injured by this. And I'll show you why no one, and obviously, that there's a bench just down there that was absolutely destroyed. The boardwalk took all kinds of direct hits. This is the reason why no one was injured. Here is a Google Earth perspective of the region. So Black Diamond Pool is that pool right there. That's where the source of the explosion is. That's Sapphire Pool. For those of you who know the area, Jewel Geyser, which erupts about every 5 minutes. It's right down in here. The Firehole River's right there. The video we saw where the person was running across the bridge, they were running down this way. So that's what it looked like before the event. This is a helicopter photo taken later that morning. This is the debris field, sort of through there. So you can see most of the debris field was over here. That's because the blast was sort of directed. It was kind of aimed at an angle towards the river. And so all of the big blocks fell on this side. In fact, there was, well, I'll show you a photo in a second, there was one block in here that was the size of a refrigerator. So it was very fortunate that it went in this direction, because if it had gone the other way, you can see it would have impacted far more of the boardwalk. It might have been much harder to get out of the way. So in many ways, the reason there was no injury is we're sort of dumb luck that the thing was directed more towards the river than back towards the boardwalk. There's the fridge. This is about 1.5 feet. And then all of these other rocks, those shouldn't be there either. They weren't there before July 23rd. So obviously a pretty impressive event. Let's talk about another event. I was super excited about this event until, July 23rd. Last year, we put in a brand new monitoring station in Norris Geyser Basin. It was in the middle of the basin, and it was specifically designed to look for hydrothermal events. We've sort of been avoiding the geyser basins, to be honest, with our seismic monitoring and our ground deformation monitoring, because if you want to locate a magnitude 1 earthquake that's somewhere in Yellowstone, the last place you want to put your seismometer is right next to a bunch of boiling water, right? You can't hear anything. The boiling water is too loud. So we've been avoiding the geyser basins. Well, we now have a really good handle on all of the background seismicity, ground deformation at Yellowstone. So it's time to get into the geyser basins. So this is the first site that we put in specifically for monitoring hydrothermal activity. This is a GPS station, so it's measuring how the ground is moving. We have a seismometer back in this area here. It's measuring very precisely how the ground is shaking. And then in these trees, we have an array of microphones, 3 microphones. So the idea behind having 3 microphones, if sound comes towards the array, the microphones are spread out enough that it'll hit each one of the microphones at a different time, and you can tell the direction that the sound is coming from. So if there's a geyser eruption over here or over there, the microphone array would detect it in a different way. And that would allow us to tell where the directionality is coming from. If we put in 2 or 3 of these, we can triangulate the exact positions of where sound is coming from. So this was just sort of the prototype. This is what the microphone data looks like. It's a lot of noise up here. That's basically the pressure in the air. This shows the direction that noise is coming from. And this is a particular day on, I think, November 18th last year. And this is a 10-minute slice of data. I'm going to go 10 minutes into the future. Well, suddenly there's a very coherent signal. You can see large pressure pulse. All of these 2 graphs here just mean it's very coherent. It's being recorded by all 3 microphones. And it's coming from one direction. Anyone want to guess what direction that is? Steamboat. Steamboat geyser. So we heard steamboat erupt. Made a lot of noise. It lasted for about 4 hours. Wow. This thing was just saturated with noise coming from steamboat. So great, we can detect the largest geyser in the world erupting. Woohoo! It's like, it's sort of like proving the obvious, right? Here's what else was happening, though, at Norris. So this is Porcelain Basin, the Norris Museum. Here's the trail to the Norris Museum, which is right back in here. This is a little lake called New Far Lake. Those of you who've been out there, that's Congress Pool right there. Green in this photo, but it's a roiling mud pot right now. So this is from 2006. Let's advance it up to 2022. New Far is, look at how much higher it gets. And it's also blue. It went from green to blue. What happened is there were a whole bunch of features up on Porcelain Hill here that suddenly, instead of pouring water into the basin, they were pouring water down into the lake. The lake turned blue from all the silica. It rose quite highly. I had a monitoring station on the edge of New Far Lake. I lost contact with it in the early 2022 or 2023. I went out and I found the case floating in the lake. It had risen by several feet. The lake. So it was basically getting fed new thermal water from these features up there. Well, we started walking around out there in May of this year, and we found this right up in this area here. All this busted up ground. Well, how do you bust up ground like that? There's only one way. This exploded. So we had an explosion that happened, at this point we saw this, that was sometime between September, when we were last out there, and May of this year. So we started examining other data sets. Here's more satellite data. Here's Newfar, Porcelain Basin. You see there's these two blue pools right there. There's the hill. Here's the next sequence. So this is from April 2nd. This is April 21st. And those pools are completely dry. And there's no water coming down into New Far Lake. So we thought, all right, maybe something happened in April. And indeed, when we look at our pressure data from that acoustic array, there was a huge pulse that happened on April 15th at 2:56 p.m. Unfortunately, well, no, it's not unfortunate, it's probably fortunate, I don't know. The park was closed. It was winter, the park was not wide open yet, so there was no one there to witness this. But I was chatting with the one ranger who lives at Norris year-round, and he said, you know, we heard something really loud. We knew it wasn't Steamboat, but we heard something in mid-April. You know, it was about like 3 o'clock or so. So they heard this happen. They didn't know where it came from. The direction of it, we can get the direction from this, it's this guy right here. The direction from our monitoring station is exactly Porcelain Hill, that place where those blue pools dried up. So we detected this explosion. The other interesting thing, there's the explosion pulse. There's the seismic trace of the explosion. It first showed up at our station at the Norris Museum, and then about 1.2 seconds later, it showed up at our new seismometer in the middle of the basin. The fact that it took that long, I mean 1.2 seconds, that's an eternity for a seismic wave. The fact that it took that long means it was not a seismic wave. It was a sound wave. The sound was shaking the ground, sort of like a sonic boom shakes the ground, or a lightning or a thunder blast shakes the ground. This explosion shook the ground. It was that big. So we felt the sound wave with the seismometers. And this is what thrilled me no end until July 23rd. Other noteworthy explosions. These are not uncommon things. This isn't a great view, unfortunately, because of the lighting, but this is Pork Chop Geyser. Pork Chop blew up in 1989. It was preceded by a few years of chemical changes to the water, and the geyser started changing its behavior. It had a pool, it drained, it turned into a little jet, and then on one day in September of 1989, it just exploded. There were several people in the basin that saw it happen. And all of this rock around the crater is from that explosion. The crater is at least 10 feet across or so, full of water right now. That's about the same size as the one that occurred at Porcelain Hill. A little bit, the one that occurred earlier this year, a little bit smaller. And then someone mentioned Excelsior geysers being one of the big ones. Excelsior is probably the biggest hydrothermal explosion or set of explosions that occurred in the history of the park. In the 1880s, so there's Grand Prismatic Spring. In the 1880s, this whole area got blown out by a series of explosions. So they're really nothing new. These things are happening pretty frequently. And the big ones happen every few decades or so. The one that we had at Biscuit Basin was one of the largest since this occurred in the 1880s. Yeah?
Hey Mike, so talking about July 23rd, first of all, thanks for doing this. Thanks for that brilliant newsletter you sent out. Obviously, you're a brilliant man. And what I'm wondering is,
Obviously.
Black Diamond Pool. It sounds to me like it's the world's tallest active geyser.
Well, that's not a geyser. So a geyser, this is actually a good question. Is a geyser eruption a hydrothermal explosion?
But black diamonds have a history
It
of
has. So,
eruptive behavior.
so-
Those are all steam explosions.
but not very well observed ones. So, for example, black diamond didn't exist before 1902. It was there by 1912. We don't know how it formed, when it formed exactly, whether it was a big explosion or not. So we don't know much about it. It may very well have been some of the largest events. And there is a history of kind of Biscuit Basin having some explosive behaviors. After the 1959 earthquake at Heffian Lake, Sapphire Pool started blowing up all the time. It was erupting like a geyser. And then after a short period of time, it stopped. So those eruptions, I think, were 100, 150 feet or so at Sapphire. But yeah, we don't know too much about the circumstances that black diamond formed. But it may very well have been a pretty big event that no one saw. That's one of the questions I get is sort of like, well, if you say this is so common, how come we've never seen it before? Like, well, only in the last decade do we all have, video cameras in our pockets. And, it had to happen in the summertime, during the day, at a very well-visited geyser basin. And it did. And frankly, this is sort of the scenario that I was worried about. It's something that happened in the summer at a well-visited geyser basin in the middle of the day. That's sort of a recipe for bad things to happen. And we were fortunate that it didn't in this case. This was another case. The pork chop was September at Norris Geyser Basin in 1989. There were people nearby, but no one close enough to be injured, fortunately. All right, so let's get to that question of how often these things happen. Well, we have a couple of ways of trying to determine that. One is this sort of model here that looks at the annual probability of the event. So here sort of happens every 10 years, every year, every 100 years, every 1,000 years, every 10,000 years, versus the size of the crater. The largest events are the least frequent. The smallest events happen all the time. It's based on a model, and it probably underpredicts just how often these guys appear, the small ones. Something like Mary Bay, that's the extreme one. That's only happening once every few tens of thousands of years. Excelsior, well, that's probably something that happens every few decades to 100 years or so. Pork chop geyser, that probably happens every few years. Porcelain Terrace is probably in this region here. That's the one that occurred in April at Norris. Black Diamond is probably somewhere in there. So it's of the sort that might recur every decade or couple of decades, somewhere in Yellowstone. But there's a lot of geyser basins in Yellowstone. We just don't see all of them all the time. Just for reference, Mary Bay, that's Mary Bay right there on the north side of Yellowstone Lake. There's also a really cool, completely submarine crater. And that's Elliott's crater right there. And that Mary Bay formed about 13,000 years ago. Elliott's crater is about 8,000 years old. So there are a whole series of hydrothermal explosions that occurred in the north side of the lake, some of them completely submarine. All right, where are they likely to occur? Well, the most likely place for them to occur are the geyser basins, of course, where there's a lot of boiling water and steam beneath the ground. So here's a map of sort of where the geyser basins are. Different colors are different chemistries. Fortunately, these purple ones, the Mammoth Hot Springs area, the Travertine Springs, those are cool. There's no boiling water at Mammoth. There's no boiling water, you're not going to have a big explosion because you're not going to have the steam that you need to drive the explosion. So we're not too worried about explosions from Mammoth, and in fact, there's no craters out there that we know about. But these black dots represent some of the larger craters, the whole concentration here on the north side. And those are focused, so the north side up there, and then some of the geyser basins of the firewall where you get some really big ones. Part of the mechanism for forming these things is having water flash to steam. Because anybody that's ever misused a pressure cooker knows that there's a lot of volume expansion that happens when water goes to steam. You break a lot of things that way. Radiators, boilers, I was trying to get this point across, and no one seemed to know what a pressure cooker was when I was saying this. Instapot? Yeah.
This isn't really like the exact same, but if you've ever put like a can of Coke in the freezer, it'll explode because it has nowhere to go.
I could tell, I did that. But I wasn't in a freezer, I was working in Alaska. It was January. I didn't want to I had to work the midnight shift at the Alaska Volcano Observatory. I'm like, why am I going to haul the soda up to my fridge? It's plenty cold in the car. And I came out one morning after my midnight shift, and there was this brown foam all over the inside of the car. So actually, yes, that's a pretty good. Yeah, volume expansion, Coke, steam. There's a lot of power that's generated. And so any place you can convert water to steam, you can power some of these explosions. So we don't have that boiling water system in a place like Mammoth. I'm not too worried about explosion there, but some of the other geyser basins, yes.
So, we thought we saw a new steam vent funeral, I don't know what, like around the Grizzly Lake area.
I know
Is
what you're
that-
talking about.
Yeah,
Yes.
is that new?
It's new.
Yeah,
It's right by Nymph Lake.
yeah.
So as
yeah.
you are driving south towards
Yeah.
Norris, and you hit the section where it says 35 miles an hour because you go up and then go to the Nymph Lake overlook,
Yeah, on the
right as you're starting up the Nymph Lake overlook, off to your right, the west side of the road, and you see it really well in the morning. There's a pretty vigorous steam vent there. And if
So-
you pull off the road, it's loud.
Oh, really?
Yeah.
When did that happen?
Sometime in the last 2 months, I think.
Yeah,
But it's right along line with a number of other thermal features. So it's not really surprising that we have one there, because right on the other side of that hill, there's a whole bunch of things that formed in 2003.
does that happen often?
It does. Not that often where we see it in the middle of summer and drive right by it.
Yeah.
But yeah, these sorts of vents are turning on and turning off as well. There's plenty of them that just go dead. And they may or may not come back. And this is one of the reasons I love Yellowstone so much. It is so dynamic. Every time you come here, it's completely different.
Yeah, that would look pretty cool. Like
It's,
it was pretty powerful.
well, there's a pullout right there. Stop and wait for the cars to go by and just listen. And it's, yeah, you can hear from the road. It's impressive. All right, why do they occur? So I've got two answers to this question, the small one edition and the large one edition. The small one edition is pretty simple. Water, boiling water and steam get trapped underground. The plumbing systems for these things are pretty complicated. If you get a constriction, pressure's going to build up behind that constriction until it blows it out. And when it blows it out, you'll have a big depressurization event, which causes even more water to flash to steam, and you can drive a really impressive explosion. This is what happened at Biscuit Basin. Probably also what happened at Norris. You can see, too, we've got this sort of cross-section of what Biscuit Basin looks like. There's a drill hole in the parking lot of Biscuit Basin. In the 1960s, they drilled into it, so we know what's underground. 175 feet of glacial debris, sandstone, siltstone, and then you get down to this, basically a lava flow, a rhyolite lava flow, below 175 feet. I told you that geology team went out and mapped all of the rocks that came out. All they found was glacial gravel. A lot of it had hydrothermal silica on the inside of it, or on one side of it. So basically you took this plumbing system here at shallow levels in the upper 100 feet or so, and you put it on the surface. So in some ways, this is kind of a unique opportunity. We can see the guts of a hydrothermal system at the surface for one of the first times, because we responded so quickly to this. So we know it wasn't driven by something happening very deep, because there's no deep rock. It's all really, really shallow stuff. So this is sort of like a faucet exploding in your house. It's not necessarily tied to the fact that the water company just, surged pressure to your house. It's because your faucet was broken. Then we go to the large ones edition. Now we have found some really big explosions in Yellowstone. One of the ways we do it is by sampling the sediment at the bottom of lakes. So this is a little coring platform on Yellowstone Lake. They can recover these cores, and they see ash layers in the cores. There's a lot of sediment in there. Some of the ash layers, we know what they are. That little ash layer right there is from the eruption that formed Crater Lake in Oregon. It is an awesome marker bed because it's everywhere. So you see that, that right there is 7,700 years old. You can put a pin in it. That is about 8,000 years old. That ash layer is from when that submarine crater, Elliott's crater, formed. So there are a couple of really nice marker beds like this. The Glacier Peak eruption in Washington, 13,600 years ago, that laid ash all over the Yellowstone region. That's another marker bed we use. And so marker beds like that help us sort of figure out how all of these big explosions occurred. So Elliott's crater sent a couple centimeters of ash all over the main part of Yellowstone Lake, Mary Bay sent up to 10 centimeters of ash all the way out to West Thumb. And of course, right in the area of Mary Bay, something like 40 meters, like 120 feet of ash right there. The plume probably went up several thousand feet and would have swept out a few miles. So, pretty consequential event. Not a volcanic eruption, but that probably doesn't matter to you if you're somewhere in that area. What's more, how do these big events occur? They really probably need to be triggered by something. And if you look at the rocks that are right on the shore, if you go out to Storm Point on the north side of Yellowstone Lake, there's a really interesting sequence of rocks. The bottom is a bunch of squiggled up sediment. It looks like an earthquake. It might be an earthquake. There are faults that run all through Yellowstone Lake. If one of those faults ruptures, you could have a magnitude 6.5 earthquake. And that could have deformed all of that sediment. All right, so now you've just moved the bottom of Yellowstone Lake in a magnitude 6.5 earthquake. What do you think happens next? Tsunami. So now there's a tsunami. In fact, there's tsunami sand sitting right above all that deformed sediment. Now you're moving huge volumes of water back and forth, including water that was sitting on top of Mary Bay, which is an active hydrothermal system. You pull that water back into the lake because of the tsunami, and maybe you're running it out the whole lake itself because you're eroding that lake outlet. You've just depressurized a geyser basin. What happens? Water flashes to steam and kaboom. So, the possible sequence here, based on the rocks we see, is there's a magnitude 6.5 earthquake, triggered a tsunami, caused a flood down the Yellowstone River, and then the largest hydrothermal explosion known on Earth. It's not even a volcanic eruption, right? But that's a bad day. So these are the sorts of hazards that can affect the Yellowstone region, but these large kinds of events need a trigger of some kind. Some strong earthquake that can really rattle things up, some movement of lake water around. That's what it takes to really get one of these things going. All right, so these are not restricted to Yellowstone. You can actually find these all over the place. Just a couple examples. This is Aguashuca in El Salvador. This happened in the middle of a town. An explosion in 1990, I think. It killed 25 people. Frying Pan Lake, supposedly the largest hot spring in the world. Grand Prismatic comes in third, but obviously Grand Prismatic looks way nicer, so we'll give them the largest one. We got the nicest one. This one had some explosions in 1917 time period. Blew out a whole area of beautiful terraces. New Zealand, these things happen at least annually down there. New Zealand is very, very geothermally active, just like Yellowstone. The weirdest one that I've been able to find, so this is a bit hard to see, but this is the corner of California, the northeast corner of California. There's Nevada, and here's Oregon. There's a little place called Lake City. In 1951, a kind of weird group of hot springs exploded. Something like tens of acres of ground was blown up. The plume went up 4 miles. It was visible all over the place. This was in 1951, so there wasn't anyone out there. But people certainly noticed it. So this was just some inconspicuous group of hot springs in the northeast corner of California. It exploded because there had been some constriction that allowed the water to turn to steam, and that's all it took. So these are not just something that happens in Yellowstone. All right, so what are we doing about this then? I'm terrifying you, right? Well, one, we got to monitor these things better. And I told you already that we've been putting in more sensors in hydrothermal areas. So we got to do more seismic monitoring, and I'm really excited about infrasound, listening for these things. This is the seismic record of the Biscuit Basin Explosion from 2 miles away. It barely shows up. In fact, it didn't trigger any alarms for us. If we'd had that acoustic monitoring, we probably would have heard it and would have detected it immediately. All right, so that's monitoring. How about forecasting? Well, there's a few possible things we could do. Anomalous changes. We know before Pork Chop exploded, we had several years of anomalous activity. Before that activity happened on Porcelain Terrace in Norris Geyser Basin, there were a couple of years of the water going into Newfar Lake and changing the color of Newfar Lake and stuff. So maybe we just need to be looking for these places that are really behaving strangely. I think magnetics might help us. Magnetics and electromagnetics, because water is great conductor. And if you've got a lot of water and steam building up somewhere, you might see an increase in conductivity. Of course, you'd have to have some sensors right there, but we could do that in a few places. And then I wonder deformation too. If something is pressurizing, it's probably pushing the ground up. So it'd have to be very local. You'd have to have an instrument or some satellite data that were in the right time at the right place, but it's possible we might see some deformation. So I think it's possible that we can forecast these things, but it's also possible these things, water flashing to steam, are inherently difficult to really know that they're on their way. And that's our challenge, is figuring that out. So that's what we're trying to do with our monitoring plan, is put out more seismometers, acoustic sensors, GPS stations in the geyser basin. So this is sort of our long-term plan. This is the current seismic network, and we want to get more of them in the geyser basin. So this, for example, that's the Old Faithful seismometer. You can see there's nothing in the Firehole Basin where all of those big geyser basins are. There's no seismometer at Biscuit Basin, nothing near Grand Prismatic. Yeah?
Is there, there's no temperature monitoring on your list there earlier. Is that part of
It
how
could
you're
be.
looking for?
Yeah, it could be. Temperature monitoring, it could be. That is relatively easy and much cheaper than a seismometer, just putting a thermometer in the water. We've got some places where the temperature monitoring is telemetered, so we're radioing that information in. So there are 9 features at Norris that are, the data show up on the internet, on the YVO webpage. So yeah, thermal monitoring should be a part of this, but man, these things go up and down in temperature all the time. And I feel like it's one of those things where, hey, Black Diamond heated up and then it blew up. Well, how many things heat up? I'm looking at the Norris data.
Sure.
Things heat up and cool down all the time. And so it's really difficult to know what kind of an indicator that would be. I think that if we saw the ground suddenly start to swell and an increase in temperature, that would be setting off alarm bells.
Sure.
So I think temperature monitoring would be part of the solution, but I'm thinking that there are some things we're probably missing that we're not applying.
Sure.
When Black Diamond blew up, was there any seismic activity, any
Nope.
earthquakes or anything?
Nope, not at all. So it wasn't triggered by something external. There were no distant earthquakes like worldwide. Occasionally you can have earthquake waves that come from Alaska. This is true. This happened in 2002. Earthquake waves from Alaska came through and triggered a bunch of microseismicity. It was like somebody was shaking the can of soda. Well, there were no distant earthquakes that could explain it. There were no local earthquakes that could explain it. Yellowstone this year has been seismically quiet, which I'm happy. I'm fine with, but like last month there were only 40-odd earthquakes. So it's been an anomalously quiet month.
Can wildlife tell you anything about their movement?
I don't think so, and that's an unpopular idea. I like not thinking that wildlife know is pretty unpopular. I've said this, and no, they know. I suspect that they're probably more attuned to feeling some vibrations in the earth. Not something that we couldn't detect seismically, but
We were coming back from Red Lodge over the pass and then came through Cook City. And it was about 6 o'clock at night. The station was already closed. And there was probably 300 to 500 buffalo leaving the ranger station heading towards Cook City. And then next week was when that Biscuit Basin blew. And when we went all the way through Lamar Valley back to Garden,
didn't see a single one.
we didn't see hardly any buffalo.
Of course, there are herds in the lower geyser basin area, not too far from where the explosion happened. So, I don't know. I think there's some anecdotal things along those lines, but it's really difficult to corroborate that, because how many times do the bison say, take that particular path, right? That's the kind of data we would need to start examining that question is, well, you only would recognize that kind of behavior in hindsight because something happened, but if nothing happens, you say, well, it was a bison jam. So that's the kind of thing that we can do more documentation of to understand whether or not there are some correlations that are consistent. All right, so last bit is if you're interested in more information from YVO, we've got a number of different sources for that. One is Caldera Chronicles, which I've heard a couple of people mention. This is our weekly article. We put it out on our social media feeds. We've got an email list server. It goes out to local news sites, so hopefully some of you get it in some of the local newspapers. We also do official updates. We do something called the Volcano Notification Service, so you can sign up to get our updates via email. We put out a monthly update at the beginning of every month, and then if the situation warrants, because say a geyser basin blows up, we put out more timely bits of information. We do video updates every month as well, and then if something happens, we'll put out another update. Say this one we put out about Biscuit Basin. Those go out onto YouTube and social media. We do these annual reports. The 2023 report you can get free online. I think there's some hard copies in the Yellowstone Forever stores. And we do social media as well. So we're on Facebook, X, and Instagram, and we're happy to answer questions. And lastly, you can email us too. I mean, I love answering questions about Yellowstone because they get me thinking. And this is an example of one I got recently with somebody who was basically saying they noticed that somebody carved their name into the bacterial mats of Grand Prismatic, which is actually an incredibly common thing. How long does that take to go away? I had no clue. But I started asking around, and in talking to biologists and some of the park folks that actually have to clean the graffiti, it takes less than a year, and it comes back. So, you know, I learned something new just by interacting with this person who had a cool question. So that's all I had in terms of sort of a formal chat, but I'm happy to keep talking. And there's a couple of other folks here that might be willing to chat as well. So Liz Westby in the back is a colleague of mine at the Cascades Volcano Observatory, and she actually does all the editing of all the video content that you may see, so she's brilliant. And Stan Rudensky, where's Stan? Stan is a USGS employee who lives in this area, has been working in Yellowstone for many, many years, and has been a huge help with hiking like 18 miles a day to carry batteries out to distant sites. So they may be able to help you too. Yeah. Thank you, Stan. Yeah, so I'm happy to answer any questions about any geologically oriented things. Yeah.
Will Biscuit Basin be open?
No,
Will
go ahead.
Biscuit Basin be open for the winter season?
I doubt it, because one, the boardwalk is totally wrecked, and two, there are still events from Biscuit Basin. Another bit that happened after the explosion was that seismometers were put out all around the area. These seismometers look like coffee cans, and they're put out because when something's making a lot of noise, you can sort of track the location of the noise and get a sense of what the plumbing looks like. This has been done in Real Faithful and Steamboat Geyser and Cistern and a number of other places. These seismometers have detected about 10 to 12 surges. And a lot of these have happened at night, so the cameras that are out there haven't caught them. But there appear to be surges that are moving rocks, redepositing more sediment. A couple of the seismometers have knocked over by surges because they're in the outflow channel. So there's still stuff going on there. So not only is the boardwalk wrecked, the Biscuit is still behaving in a weird way. So I think the park is going to be pretty cautious about reopening.
Couldn't just open the parking lot so we can drive through?
Anyone here from the park?
Could you call them?
Yeah.
Did you have any, like, concerns, hunches, anything about Biscuit Basin before it erupted? 'Cause
No.
in our guide training, you said something like, I don't know, like, we often don't notice these smaller hydrothermal eruption events, but it could potentially be really bad if one happened next to a boardwalk in the middle of the day. It kind of made me wonder if you knew.
No, I would, yeah, the Oracle of Simpsons. No, this was, what I was expressing during some of that, the talks I was doing was sort of my big concern. You know, like what I answer questions all the time about like, when's Yellowstone going to have a volcanic eruption? Never! I mean, it will at some point, but it's not something we're going to have to worry about. What I worry about is exactly what happened on July 23rd. And so I think what I was expressing is like, that's my fear. What happened on July 23rd was my fear. I didn't know it was coming. I was really hoping that I would not ever be around to see something like that. But on the other hand, no one was injured. I don't think it's I don't think it's as underappreciated now because of all these viral videos. And it is getting us a window into these processes that we normally don't have. So I'm hopeful that we're going to be able to turn this into a real positive and better understand these sorts of explosions so that we can be at least better prepared for their occurrence in the future. So it's strangely fortunate, but I feel bad saying that because it could have been pretty bad if the explosion had gone the other way. Is there a question back there?
Yeah, I was curious after that car drove into semi-centennial geyser, if it started acting strangely or if anything was noticed.
Not to my knowledge, although you were just saying that it's changed its color?
It
It looks like it's cleared up,
Okay.
It was greener than it used to.
Yeah,
and there's more
Yeah.
steam to it.
There is a tire still in there. For those of you that hadn't heard, a car drove into a geyser it was a geyser that was really blowing up a lot in like 1922, and ever since it's been this sort of pool. And yeah, I've driven by it a zillion times and never really noticed it. And yeah, no, it is that green color is sort of new, isn't it? There was a lot of oil that came out of the car. Did that have something to do? I don't know. So I don't think it's behaved any differently, but certainly it looks different. And
Was it a green car?
When it came out, it was gray, but I don't know what color it was.
How many of those monitoring stations do y'all have in the park?
The seismometers?
Yeah.
There are 46 stations all throughout. Some of them are slightly outside the park, but there's 46 in the region that we use for locating earthquakes in Yellowstone.
So do you have more like in the northwest section? Because when you showed that map earlier,
Yeah.
it looked like there were a whole big cluster of bigger earthquakes to that part of the park.
Yes. So this is the main seismic belt in the park, because the Hebgen Lake earthquake happened right out here in 1959, and there's seismicity that just trends in all the way to about Norris or about this area here. So the heaviest zone of seismicity is in here. It may be that we're still getting aftershocks from 1959, or the earthquake changed the stress, sort of like a crack in a windshield, right? It sort of changes all the stress in the windshield, and you can see other cracks propagate. So ever since 59, this has been where all of the not all, where the bulk of the seismicity is in Yellowstone.
So are the yellow ones, sorry, I'm sitting in the back and can't see very well, but
Take an eye.
are the yellow ones, the pale yellow, the ones that exist now?
So the yellow ones are, we call them short period, which means they're sort of older models. We are trying to gradually upgrade all of the yellow ones to be blue. The blue are the state-of-the-art sensors. They can detect all kinds of frequencies of shaking, all kinds of directions of shaking, so they're really a modern seismometer. So a lot of the seismic network in Yellowstone went in the 70s and 80s, and some of those stations have not really been upgraded since. The broadband stations really started coming of age in the last 2 decades, so we're going to try to turn this map red, blue, and orange. We want to get rid of all these yellow stations. And we've replaced, so far this year, I think we've replaced 4. So this map isn't even current yet. And we've got a couple more to do yet this year.
So are you placing those stations based on what's underground or what's on the surface?
Mostly based on what's at the surface. But we've been avoiding the geyser basins with these. And this guy right there is the first one that specifically went into the geyser basin for the purpose of monitoring hydrothermal activity. So I think what you're going to see, hopefully in the next few years, is that there'll be some more ones, like some more of these will turn blue, and you'll start to see more of these stations in places where we've got some of the big geyser basins. So we've mostly been avoiding those, though. Yeah.
Can't you use sound cancellation technology to filter out boiling water sounds?
We can to an extent, but the boiling water sounds span a frequency content that interferes with the earthquake. So it's all about frequency filtering, and we can get rid of some of it, but not so much that would allow us to see really small earthquakes. So we do, it actually works very well with people walking around and with cars. So there's a couple of these stations, like Madison River. That thing's right next to the West Entrance Road. And we see cars all the time, but those can be filtered out. And we see a lot of people walking around at Norris Museum. Norris Museum is really noisy seismically from about 8 in the morning until about 6 in the afternoon, in the summers. But we can filter that out too. But boiling water spans a frequency spectrum that's a bit harder to filter. Yeah?
Since you were talking about how the larger hydrothermal explosions need triggers, do we have any evidence that when glaciation was melting out rapidly, or when the Hayden Valley ice dam erupted, like that we had hydro?
Good question. Yeah, so when we unloaded this by melting all the ice, were there a bunch of explosions?
Yeah.
That was the initial hypothesis, that all those big explosions by the lake, which were driven by deglaciation. So there was about a kilometer, about a mile and a half of ice sitting on top of the Yellowstone region until about 14,000 years ago. Mary Bay formed 13,000 years ago. Then you've got Turbid Lake, that's 9,400 years. Elliott's Crater is 8,000. Indian Pond is 3,000. So there's not really, there used to be the idea that you take the ice away and suddenly there's an unloading and kaboom. But that's not really what seems to have happened now that the dates are a little better. So it doesn't look like deglaciation had as big an effect as we might have thought. So, yeah.
So talking about monitoring in efforts to predict these types of things, do you think that there might be enough like buildup that you would observe before a hydrothermal explosion to actually be like a warning system, or do you think it would be more of like a rapid onset where it's like you can't really do anything about it anyway?
Yes. I think in some cases with the small ones, there's probably not a lot we're going to detect. I am hopeful that if we had the right data from the right place at the right time, there's a fantasy, we could forecast these things. And so, you know, if we had, say, electromagnetic monitoring at Biscuit Basin, I wonder if we wouldn't have seen the accumulation of something really conductive as all that water and steam built up. Or if we had deformation monitoring right there at Biscuit Basin, would we have seen the ground swelling in an imperceptible way to people that are walking around, but we can detect millimeters of change, right? And suddenly you see something doing this. So I'm hopeful that yes, we would be able to forecast these events, but we need the right data in the right place at the right time. And that's tough. I mean, we could run out and instrument the heck out of Biscuit Basin right now, and then something else behind us will have an explosion. We run over there. It's like whack-a-mole, right? So I don't know, but I'm hopeful. Yeah.
How many stations would you like to see in the park?
It's an interesting question, because if there's no boundaries whatsoever, right? I'd love to see some of this acoustic monitoring in every major geyser basin. A couple of stations, but there are some realities. It's not cheap to put this sort of monitoring in. It also can be a blight on the landscape. We work very hard to not put this stuff in really obvious places so that there's not solar panels and battery banks as you're walking down the boardwalks. So we've got to find the right places for those sensors. But there are a lot of good places to put those. There's also a time factor. Installing one of these stations takes a fair bit of effort. Maintaining it takes effort. So I could say like, oh yeah, I want 3 modern seismometers, acoustics, GPS in every geyser basin in the park. And that's 100 stations. Well, who's going to maintain that? Good grief. I mean, talk to Stan for taking batteries out to the middle of Mary Mountain. So I think we need to start by putting a few stations in key geyser basins. So like the ones along the Firehole River, Norris, maybe Mud Volcano, and start learning what those are telling us. And then I think we can better answer that question of how many do we really need to do this well? Because we just have the one at Norris, it's difficult to know, but the one at Norris proved to be incredibly valuable. And so we're going to try to put probably more into Norris soon, and then also move into the upper geyser basin for obvious reasons. Yeah?
If you had your choice of where to put in the next acoustic monitoring station, irregardless of logistics and permitting, where would you put it?
I think I'd want to put it in the upper geyser basin. I mean, if nothing else, you would hear a lot of geysers erupting, which would be super cool. Right? I mean, you'd be guaranteed really interesting data. And then if something happens, you would hear it and be able to triangulate its position. And actually, there's cell coverage there, so you could use the telemetry is easier. So I think that should sort of move up our priority list for where something should go. Yeah.
Several years ago, Ear Spring exploded.
Oh, yeah.
I haven't heard any mention of it in everything leading up from the Biscuit Basin up to the day. Relatively speaking, how big was it?
Pretty small.
Okay.
Ear Spring's a weird one. So Ear Spring is a cool little feature. It looks like an ear, obviously, in Upper Geyser Basin. And in 2018, it had an eruption. And it has eruptions maybe every few decades. But what made this eruption interesting was that it brought a lot of human garbage to the surface. So there were like coins all over the place. A cinder block came out. Hats. There were cans with pull tabs. Right? People remember those? Or am I the only one? There was a pacifier that came out. It still said "Made in the USA" on the pacifier. So a couple decades of stuff that fell into the pool or were thrown in and then got ejected back out. Was that an explosion? Yeah, I think I would put it on that spectrum. It didn't form a crater. It sort of came from an existing crater, but it threw stuff out. And there were rocks that were scattered out over the area. But that's really on the really low end of the spectrum. Something like Ear Spring probably happens more than once a year somewhere in the park. But we don't often see those.
So, if my understanding is correct, Biscuit Basin got its name because of some large biscuit-shaped rocks in and around the pools. Do you think those were from a previous explosion?
Oh, shoot. You know, what kills me here is that we have a Caldera Chronicle article about Biscuit Basin and how it got its name. And I'm drawing a blank right now. Does anyone else know the history of that?
I think it was biscuits that had been formed like geyser eggs.
Yeah.
And then got washed into the river. Like some of them ended up washing into the river.
And I think after 1959, because of all the activity from Sapphire, I think it was around Sapphire Pool, they stopped forming. And they're largely gone now. So I think those were sort of evidence of kind of activity that had been there in the early part of the park's history that's no longer occurring, and then you can't find those things anymore. Or at least they're not as prevalent. That's what I remember. But if you do a search for like Biscuit Basin Caldera Chronicles USGS, you'll find the article that I edited, so I should know more about it. But yeah.
Mike, can you talk a little bit about the changes that have been going on at West Thumb?
West Thumb, ooh, yeah. So down here, West Thumb Geyser Basin, West Thumb is incredibly dynamic. I was chatting with some of the rangers, and they said that they feel like left out. And some people refer to West Thumb as Dead Thumb, which is mean, right? Because it's not. It's super dynamic. There are things changing there all the time. There's one feature that's sort of been nicknamed dynamic feature or dynamic geyser, because you walk by once, it's full of water. You walk by later in the day, it's empty. The day after that, it's black. The day after it's blue. You know, I mean, there's so much changing. The big change happening right now is Abyss Pool. Yes. And Abyss normally is sort of dark colored, and now it is a brilliant blue. And it is a lot hotter than it used to be. It's gone up many tens of degrees. I think the latest temperature reading they're getting is somewhere between 170 and 180 Fahrenheit. And the lore is that the last time Abyss heated to the boiling point at that elevation, it exploded. So, why is that happening? I don't know. All of the changes that are happening are pretty shallow and restricted to the plumbing systems of these features. There's obviously a lot of weird connections at Biscuit, and sort of, thermal energy seems to sort of migrate around the basin at different times, but why exactly it's happening, I don't think we have a good handle on. But Abyss definitely bears watching. That's some interesting stuff happening there.
I mean, anything about that guy who was in it?
I didn't want to talk about that. So, Abyss is the site of the most recent thermal-related fatality in Yellowstone. There was a person that no one saw it happen, so we don't know what happened, but he basically went into the abyss and didn't come out. Yeah, I can't imagine that a human body would do anything, you know? I hope it doesn't explode.
But from like 2014 to 2019, or maybe even 2020, it was blue.
Yeah.
And then it
cooled down again.
It dropped
Yeah.
in level and turned black. So it has.
It goes through these cycles. Yeah, I think in 2014, it was the last time it started to get pretty warm, and then it went down again. So yeah, hopefully it'll kind of go back to sleep. But
Do you know when the eruption in the lore, any idea what date that was?
1994, 2, early 90s. I bet you it's in the geysertimes.org database for Abyss. But or in Janet Jones has an article or a little book on West Thumb. It'll be in there. It's early 90s. Hey, so it's 7:30. I don't want to keep you guys here when there's dinner to be had and so forth. But you know, sure.
How many people have been to Craters of the Moon?
Oh, I have.
Yeah.
Place is
In
awesome.
order to, and that, to me, that board they have in there that shows where all of the hot spots along from Oregon, Washington, and all the way over here is a fascinating.
There is a swath of volcanism that spans across Idaho all the way to Yellowstone. And that's the track that basically this volcanism, this fixed hotspot, has taken as the North American plate has moved over. It's like it's carved a chunk of Idaho. If you look at a map of Idaho, you'll see the Snake River Plain, and it's just this, it's like somebody carved a chunk out of the
It's a
mountains.
fascinating exhibit.
Yeah.
The other thing is when Mount St. Helens blew in 1980, the dust from Mount St. Helens landed at Grand Junction, Colorado, before it landed in Southern Oregon.
There's some really weird atmospheric stuff that happened. There's also like a weird pod of Mount St. Helens ash that landed in Oklahoma.
Oh.
But not in the surrounding areas. So yeah, the atmosphere can do some really super weird things when there's ash floating around. So yeah, that was an interesting eruption from that standpoint. I don't want to keep you here any longer, but I'm going to stick around and we'll actually turn some lights on because it got dark. And if you want to chat some more, I'm happy to stick around and answer questions. But thank you all for coming. I really appreciate it. If you'd like more information on how to sign up for Caldera Chronicles or the Volcano Notification Service, Liz can also help with that in the back.